Welcome everybody to this series Olympiad training activity. This first sequence will be about shortlisted inequality. Find the largest real number alpha such that for all finite increasing sequence with this term is equals 0, we have to prove this inequality. Dear contestant, I remind you that a magical way to solve mathematical Olympiad problem might be following the equation knowledge plus intuition. By knowledge, there is some concept, might be geometrical, algebraic, combinatorics, or number theory, and there are some related theorems, and there is a set of techniques for solving those problems. By combining those tools, using a good part of intuition, one can find elegant and short solution. Okay, by setting this new notation, we have that this sum E from Y to K equals. So, one can now think to use the Cauchy-Schwarz inequality. So, times it's classical that this is greater than K square. So, by dividing by this term, we'll find greater than. Now, now observe that this term is unfortunately not so close to the right hand side of our inequality. So we must to do some change in this term by adding by using such sequence to be determined in the following of the reasoning. We have that this is greater than 2k square, and now the same reasoning gives ci square over yi is more than square over xk. And here, now we must choose in convenient way the sequence ci in order to point out the term k plus 1 to obtain the fraction k plus 1 over xk. Okay, now let me to set that ci is equals to the binomial coefficient e plus 1, 2. And so, by a combinatorial proof, here, 2k is equals to, we add here 1 and here 1, k plus 2, 3. This term is explicit. It equals now e plus 1 over 2. And so our inequality here becomes e square, e plus 1 square over 4y I to k is greater than, and here it's also calculable. It gives k, because there is a square here, k square, k plus 1 square, k plus 2 square, and there is some factorial 3, so we will have 36, and this denominator xk. Okay, please now try for some minutes to complete the solution. Now, by managing this expression, the last inequality, we will obtain 9 by simplifying over k square, k plus 1 and k plus 2 square times this e from 1 to k, and here e square, e plus 1 square over yi, and this is greater than k plus 1 over x sub k. Okay, and now we have to sum all those inequalities, because now the k is less or equals than n. So we can to sum those inequalities to obtain the right hand side of the first inequality. So we have to, now we have to do double summation. So we can, if we want to simplify, name this term is a sub k, we have to do now the summation k from 1 to n ek, and here this quantity e equals 1 to k, e square, e plus 1 square over y a, and the wanted expression here is k plus 1 over x sub k, k 1 to n. Now we want to express this in the following expression. Say a1 over y1 plus a2 over y2 and so on, plus a sub n over y sub n. To do this, we have to use a switch formula which allow one to change the order of summation. As I said before, now I will to write this term under the form a1 over y1 plus a2 over y2 and so on, plus a sub n over y sub n. Now, to do this, or to do so, I need to switch the order of summation. Try, please, to do this idea here. Okay, as I said before, we will switch the order of summation. So, this member becomes, the first now starts by E1 to N, and here, pay attention please, we will start from I to N, because K is greater than I. And here we have the EK, 9 over K square, K plus 1, K plus 2 square, okay? And times this term, which is independent from K, I square, I plus 1 square, okay? And over Y, I. So, now for such M less or equal than N, one has to calculate easily the coefficient A sub M. So A sub M will be equals to A sub M, it's just summation K from M to N, 9 over K square K plus 1 times K plus 2 squares times M square times M plus 1 square. Now, by straightforward calculation, one can see that this expression, this fraction, gives a kind of telescoping expression, which is equals to Km to N 1 over K square K plus 1 square minus 1 over K plus 1 square times K plus 2 squares, and all times this coefficient M square M plus 1 squared. Okay. Few moments please to complete this calculation. Okay, now finishing this calculation, we obtain this expression, which is clearly less than 9/4. So each constant is less than 9/4. So recall that we have proved this inequality, and so by optimizing all those constants, we obtain that 9/4 sum of, return now to the first notation, xi minus 1 to n will be greater than this quantity over xk. And we see that if we invert it here, so the number 4/9 is admissible as solution, is admissible. But it remains to prove that is the largest constant, which will be the subject of this last step of the solution. Okay, in this final step, now we suppose that alpha is an admissible real, which verify this. Our goal is to prove that alpha is less or equal than 4/9. To do this, we will construct a sequence which give us this statement. Fortunately, this is a convenient sequence constructed in this way by adding that x is equals to 0. I recall that this work is from the problem selection committee of IMO 2017. Okay. Now, by straightforward calculation, one can find easily that this sequence is I plus 1, I plus 2 times 1/3. And so this expression this expression here, it's equals to 1 over I plus 1 from 1 to n, which equals to 1 minus 1 over n plus 1. This is the left hand side of this inequality. And for the second, we see that e plus 1 over x sub I, it is equals to 3 over I times I plus 2, which can write in the following: 3 over 2, 1 over I minus 1 over I plus 2. Okay? But to calculate easily, we add a term and we subtract and add the same term, minus 1 over I plus 2. When summing, we will find that this summation, it is equals to sub I to n. It's equals to the first term here, it's equals 1 minus 1 over n plus 1, and the second here, it's equals to 1 half minus 1 over n plus 2. Okay, now it remains to conclude. We conclude now with those last lines. Let n tend to infinity, so we will obtain here 1 is more or equal than 3 alpha time over 2, and here 1 3 over 2, so which implies that alpha is less or equal than 4 over 9. The solution is now complete. Thank you for watching and see you in the next video.